Students, good morning. Today, we're going to discuss about the free energy. Here is free energy. It is called as work function. Work function. Today, I'm going to discuss about the brief information on Helmholtz free energy or work function. The notation for Helmholtz free energy is A. Mathematically, it is defined as A is equal to U minus Ts. This is the empirical form. U stands for internal energy. T stands for temperature. And S stands for entropy. Clear? Internal energy, entropy, temperature, all are state function. This by default, Helmholtz free energy is a state function. It's a state function used to define the state of the system. It is a state function. Moreover, it is an extensive property. Extensive property. That means it is independent of mass of the system. Extensive property. Sorry. This depends on the mass of the system. It is an extensive property. Okay. Now, to understand the physical significance of Helmholtz free energy, physical significance. Physical significance or importance of Helmholtz free energy. Let us consider the reversible isothermal process. Reversible isothermal process. Now I am going to differentiate this equation. A is equal to U minus Ts. On differentiation, dA is equal to dQ minus differentiation of the product of temperature entropy. With changes in energy, absorption is equal to du minus T ds minus F into dt. We are considering this process is isothermal, hence this term gets cancelled. So the final thing, dA changes in work function is equal to du minus T ds. T ds is sigma. The second law of thermodynamics is dQ by T is equal to changes in entropy. dQ is equal to TdS. Now I am going to substitute dQ instead of TdS in this equation. First law of thermodynamics says that T is equal to dQ minus dW. Underneath TdS is minus dQ. That means reversal heat exchange. These two terms are gets cancelled. dA is equal to minus dW. Or I am going to write like this: W is equal to minus finite difference in Helmholtz free energy at constant temperature. The process is reversible. I am going to mark surface or as for reversible process. What is the information from this equation? This is decreasing not function accompanying a process at a constant temperature. T. What is this? Left hand side of this. This is the reversible work done. Reversible work done on the system during the change in state 1 to 2. Clear? This is the amount of work done, reversible work done by the system. This is decreasing work function of the system. Minus sign indicates decreasing work function. Clear? Since it is a reversible process, this work is nothing but maximum amount of work done by the system. This is the maximum amount of work done by the system because it is a reversible process. In actual condition, that means irreversible process. In actual condition or irreversible process, the decrease in work function. Listen, this is the minus sign. The decrease in work function will not be equal to the amount of work done by the system. This is equal if the process is reversible. The process is irreversible. The decrease in work function, the amount of work function gets decreased, will not be equal to the amount of work done by the system. In such a case, W for irreversible process is less than that of decrease in work function of the system at constant temperature. Clear? This is the brief information about the Helmholtz free energy. Thank you.